Gang, why were the Vikings so good at navigating? Well, we're going to learn one of their secrets. We're going to need for our experiment a match, some press stick, a pencil, piece of paper, and some sunlight and some stones to stop the bit of paper flying away. It's about 9 o'clock in the morning. I've made my first mark at the end of where the shadow, you see the shadow being cast by the match? I've made a mark there. I'm going to repeat this operation throughout the day. The more times I do this, the better. Again, I've marked another line, 11:30. The more frequently you come out and mark your line, then the more accurate the line is, or mark crosses at the end of the shadow, the more accurate is the line you'll draw along there. But that doesn't really matter. Not a train smash. Right, so I'm done. We have made ourselves a Viking Sun Compass. How have we done that, sir? Well, what we did, remember, I'll cheat now. We drew, or we put this on a surface, a flat surface, matched on a bit of paper and left it for a day. I started at about 9 o'clock in the morning and marked where the shadow went, where the tip of the shadow went through the day, and finished about 3:30 in the afternoon. And then I drew a cross on the end of each of those, and then I've drawn them or joined them up dot to dot, and we end up with a genome curve. So that is just a line that shows us how the sun's moved through the sky at this particular latitude during the day. Now, there's some problems with sun compasses, which we'll go through in questions, and I'll find a way of asking you about those problems, but I'd like you to start trying to think about that. But how do we find north? So enough of this nonsense. Tell us how to find north. How to find north is quite easy. Just turn the sun compass so that the shortest part of the shadow is touching the line. So that's not north now, look, because that's a long way away. So just turn it, holding this as flat as you can, shortest part of the line, it's about there. Now, it's, as they say, good enough for government work. So that line is north-south now. The northern side is the tip of the match, and the southern side is on the genome side. If we are in the southern hemisphere, if we are in the northern hemisphere, this will be the other way around. The match would be on the southern side. So anything on the left-hand side of the bit of paper, where the G is, that's roughly west, and the right hand side is east. So that is how the Vikings managed, when the sun was out, to find north before magnetic compasses were a thing. And it worked pretty well for them, but they were quite clever with their navigation. They actually built villages in places on the coast where they knew if they stood headed off on one of the major headings and stayed on a major heading, they were very likely to hit something at the other end. And their longest track for one of their built villages was 2,500 kilometers on a westerly heading. So they were pretty clever-os. They knew navigation, and power on the oceans, that was an important thing. Anyway, I'm ranting, enough of this. That is how to make a Viking Sun Compass. If you'd like, I'd like you to have a go and send me the results. I'm excited to see what you do with it, and we'll try and find out the problems. But good enough for now.